Sixth grade lesson 10.8 is problem solving, changing dimensions. Dimensions meaning the measurements of the sides or the lengths of the sides. So you're going to be looking at things that are one size and they either increase to a larger size or you're going to have something that starts at a larger size and decreases to a smaller size. To give you some 8th grade terms, when you're changing the size but not the shape of something, we call those dilations. You'll talk about those at 8th grade. And this makes sense to you because you know pictures, but dilations are if you increase the size, you've enlarged it, like you've enlarged a photo. You do that a lot on a tablet where you just pinch outward to enlarge something and make it bigger. Or I guess you pinch inward to make, no, that would be smaller. Pinch outward to make it bigger. Pinch inward would make it smaller. That's called reduction or reducing the dilation. So I just wanted to give you a little bit of a peek at what that vocabulary is at 8th grade. But let's go ahead and refocus back down to the 6th grade level of how they want us to recognize this, what they're going to show us. And I think that the best way to show you is exactly the way they walk you through in the book. So I'm going to use their pages to walk you through what they're trying to get you to recognize so that you can use that to your advantage. Okay, so we have Jason has created a 3-inch by 4-inch rectangular design to be made into mouse pads. I don't even know if you guys know what mouse pads are anymore. They're not beds for little mice. They're the little pads like people who use computer mice. The little pads that those track on. Anyways, so he has a rectangular shape, 4 inches by 3 inches. They say to manufacture the pads, the dimensions will be multiplied by 2. The dimensions, the lengths, will be multiplied by 2, 4 times 2, 3 times 2, or maybe multiplied by 3. So 4 times 3, 3 times 3. And so we probably could pretty quickly do the calculations of how that changes our dimensions, but their question is, how will the area of the design be affected? Remember, area is length times width, the whole flat surface. So they want us to know, what do I need to find? Now, normally when you get into the lesson, you're just going to get questions like this. You won't get this whole planning session out. Maybe you can do it in your head, or maybe you like having the planning session and you just go ahead and get a piece of paper to allow for planning till your brain gets the hang of things. It's a good thing to do. What do I need to find? I need to find how the area will be affected by changing the dimensions. So how will the area will be affected by changing the dimensions? And the two ways they were going to change the dimensions were going to be times 2 or times 3. 2 times bigger or 3 times bigger. What information do I need to use? I need to use the original dimensions, so the dimensions of the original design, and I will multiply them by 2, and then I will also multiply them by 3, because they said it would either be doubled or tripled. I can draw a sketch of each rectangle and then calculate the area of each one, and I can look for the relationships or the comparison of my results. Okay, so if we took the original dimensions of 4 for the length and we multiplied it by 2, 4 times 2 is 8, so they did that one for us. And if I did the height by 2, that's 3 times 2, which is 6. So they ended up with dimensions of 6 inches and 8 inches. The multiplier was the 2. Now if our multiplier is the 3, then I would do this 12 times 3. I'm sorry, no, my bad. This 4 times 3, they did the math for us. 4 times 3, which gave us 12, they did that for us. And 3 times 3, which is 9, they did the math for us. So we get dimensions of 12 by 9. Once I have the new dimensions of these enlarged shapes, these mouse pads that we've enlarged so that the mouse can track on them, we would find the area. They're rectangular, so we use area equals base times height. For the original one, they did 3 times 4, which is 12. I'm going to circle that because we're going to, area of original was 12. Area of the times 2 version, let's find out. Our new dimensions are 8 and 6, and 8 times 6 is 48. This is inches square for both. And then on this last one, we're doing area. I want that to be blue. Area equals 12 times 9. And 12 times 9 is 108. So the area of the times 3 version, the enlarged by 3 version, is 108 inches square. Okay. When we took the original amount and we multiplied this dimension by 2 and this dimension by 2, our area became 48. That's 4 times bigger. You might have thought, oh, well, the area is going to be 2 times bigger because we multiplied by 2 multiplied by 2. But it ends up being 4 times bigger. But think about it. I increased this by 2. I didn't increase it by 2. I doubled it. I multiplied it by 2 here. And I multiplied it by 2 here. And when we're doing dimensions of our rectangles, we're doing length times width. And we multiplied both sides by 2. So it was 2 times 2 more. So it is 4 times bigger. So when the dimensions are multiplied by 2, the area is multiplied by 4. Because 2 times 2 is 4. And we have to do both dimensions, both the length and the width. So if that's the case, think about what it would be for when we multiplied each side by 3. How much bigger was 108 compared to 12? If it was increased by 3 this way and by 3 this way, 3 times 3 is 9. This should be 9 times bigger, and it is. So when dimensions are multiplied by 3, the area is multiplied by 9. The squared version, to the second power version of the amount we increased it by. So that was the pattern they were wanting you to see. Is, okay, well, if I increase each of these by 2, then this increases times 2, and this increases times 2. But how does that affect area? Because I do this times that, you've got to consider what 2 times 2 is on the increase of the area. So if I knew that the area was 12 in the first place, and they said, now we're going to go and increase all of our dimensions, all of our lengths times 2, then in your brain you could go and say, okay, well, let me times 2 and times 2. But now that you've seen what they've brought us through, you can go, oh, I'm multiplying this area times 2 this way, times 2 that way. So that's a total of times 4. 12 times 4, 48. So that's what they're trying to give you that shortcut to. They're trying to get you to recognize that if I double my lengths, that's going to make my my area 2 to the second power, times 2 to the second power, or 2 times 2 is 4 for the doubling. So that's what they're trying to get you to recognize on there. I hope I explained that well and didn't confuse you. We'll look at another example. Okay, next example, we've got this triangle. A stained glass designer is reducing the dimensions of an earlier design, reducing it, making smaller. The dimensions of the triangle shown will be multiplied by half, so you'd be cutting it in half, or 1/4, so you'd be cutting it in fourths. How will the area of the design be affected? Use the graphic organizer to help you solve the problem. Again, you're going to get a lot of word problems like this without them walking you through, but you could use, if you like having this graphic organizer to kind of guide your thought process, use a whole piece of paper every time you solve these to kind of organize your thoughts. Could be very helpful at first. So what do I need to find? I'm going to find the area of this one, and then I will find the areas of the smaller dimensioned ones. So to word that easily, area of original and new dimensions, so I can find the area. What information do I need to use? The original dimensions, and then calculate new dimensions. And I know you saw those fractions and you went, oh no, fractions. Think about it this way. It's a really good chance to practice again and dust off those cobwebs. Imagine if you learned that skill at last year and never reviewed it all the way through, and then you were expected to use it again at 8th grade. you wouldn't have held on to it at all. So periodically, it's good that they keep making us do that because it sinks further and further into our brain. How will I use that information? I will get the new dimensions, and then I will find the area of the new size, the reduced size, and then I will compare those areas. Okay, but before we do, I want to kind of make you start thinking about it. How does my area change if I cut it in half? So think back to the previous example. When we doubled it times 2 on both dimensions, we did 2 times 2, which is 4. That meant that the area was going to be 4 times bigger. If the dimensions, the length and the width were 2 times bigger, then the area was going to be 4 times bigger. So if my lengths are being cut in half, 1/2 times on one side, 1/2 on the other, then I should expect my area will be 1/4 the size, or divide by 4, right? 1/4 the size of the original. And if I end up reducing with the 1/4 multiplied by 1/4, which would be a reduction also, it will be 1/4 of 16 and 1/4 of 6. So I'm cutting one dimension in 1/4 by another dimension in 1/4, which gives me 1 and 4 times 4 is 16th of the area. So whatever the area is, divide by 16. So let's take a look at what the actual area of the shape before we do any reduction comes out to be. So again, area equals 1/2 times the base, which is 16, times the height, which is 6. Well, that half of 16 is pretty easy to do. Half of 16 is 8. Now just to brush off cobwebs on multiplication with your fractions, I can write that as 1/8, 1/2. 1/2 of 16, or 1/2 times 16. Cross reduce. 2 goes into 2 once, 2 goes into 16 8 times, and I get 1/8, which is 8. 1 times 1 is 1, and that's the same as 8. Then I'm going to do the times 6 part of that. That's 48. So our hypotheses are that if I reduce both dimensions by half, then my area is going to be 1/4 of 48. So 4 divides into 4 once and into 8 twice, so it will be 12 centimeters square is our hypothesis for this one where they cut it in half. If I cut each dimension into fourths, divide by 4, divide by 4, I should have 1/16 of the original. So dividing 48 divided by 16 is going to be 16, 30, it's going to be 3. Those are the dimensions I should get, we believe, right? So let's just stick that there for right now. And then let's go through and see what comes out of it. Now, if I do the multiplier of 1/2, 1/2 times 16, we found out was 8 there. And 1/2 times 6, or 1/2 of 6, is 3. Calculation-wise, if we want to see it, 1/2 times 6 over 1. Cross reduce, 2 goes into 2 once, 2 goes into 6 3 times. 1 times 3 is 3, 1 times 1 is 1, and that is 3. They gave that to us there. Let's do the area. Formula is 1/2 times the base of 8 times the height of 3. I can do half of 8 nice and easy. Half of 8 is 4. And 4 times 3 is 12 centimeters square. Let's try this other one. It's going to get even smaller because we're cutting each of those dimensions into fourths. So let's do 1/4 of 16, the base here. So we're doing 1/4 times 16. Cross reduce, 4 goes into 4 once, 4 goes into 16 4 times. 1 times 4 is 4, 1 times 1 is 1. So my base is 4. Now for the height, 1/4 times 6. Now 4 doesn't go into 6 evenly, but 2 goes into both of those evenly. 2 goes into 4 twice. 2 goes into 6 3 times. 1 times 3 is 3. 2 times 1 is 2. And for now, I will leave that as a fraction. 3/2 is the height right here. That is when we multiply each dimension by 1/4. Let's use the formula. Area equals 1/2 times the base, which is 4, times the height, which is 3/2. I just left it as a fraction because I already have a fraction in there. And I may as well just multiply those two fractions together since they're fractions anyway. And I'm going to get 1 times 3 is 3, 2 times 2 is 4. So I get 3/4 times 4. Cross reduce. 3 times 1 is 3. 1 times 1 is 1. The area is 3 centimeters squared. And so what we came to as our conclusion is when the dimensions were multiplied by 1/2, we had multiplied by 1/2 and multiplied by 1/2 here too. 1/2 times 1/2 is 1/4. The area is multiplied by 1/4, which is 1/2 times 1/2, right? When the dimensions are multiplied by 1/4, the area is multiplied by 1/16 because 1/4 on this one times 1/4 on this one. 1/4 times 1/4 equals 1/16. So that's their way of showing you, like, if they are cutting the dimensions by a certain amount and they want to know how that changes the area, remember you did that dimension times that dimension. So you have to do that change by that change, that change by that change. Whether it's reducing it, multiplying it by a fraction, a proper fraction, or enlarging it, multiplying it by a number that's larger than 1. So with practice, I think that will all come together. Good luck.